Welcome back to our flipped chemistry classroom, and we're continuing our conversation about nomenclature today, and we're continuing to talk about ionic compounds. We've been talking about binary ionic compounds that contain one metal and one non-metal. Now we're going to move into a conversation about polyatomic ions. So these are still ionic compounds. They're still going to contain a metal and a nonmetal, but instead of one nonmetal, they're going to contain a group of nonmetals. And that group of nonmetals is going to be covalently bonded together and then have a charge. So it is a group of nonmetals that are covalently bonded, but then have an extra electron or two, or maybe they've given up an electron or two. And so they are then ions which can be attracted to another ion. So as an example, the sulfate ion has one sulfur and four oxygens all covalently bonded together, but then it also has two extra electrons. So it has an overall charge of -2. That means it can be attracted to a cation or any positive ion, usually a metal. So these polyatomic ions will bond with other ions to form compounds. So some of our polyatomic ions are ammonium and nitrate and carbonate, as well as hydrogen carbonate, phosphate, nitrite, hydroxide. You might have noticed that several of these have the ending 8. Most of the polyatomic ions, the common polyatomic ions, end in that 8 ending. If they have one less oxygen than the 8 ending, they have an ite ending. So you notice that nitrate has 3 oxygens and nitrite has only 2, but not all 8s have 3, because you notice that phosphate has 4 oxygens, but the phosphite only has 3. So no matter how many the 8 form has, the ite always has one less than that. And then we also have polyatomic ions where we have a 8 ending, a base polyatomic like carbonate, and we add a hydrogen, and that becomes hydrogen carbonate, and it changes the charge. Also notice that the 8 ending and the ite ending have the same charge, even though they have a different number of oxygens. So nitrate has 3 oxygens and a charge of -1. Nitrite has only 2 oxygens, but it still has a charge of -1. So how do we write formulas when we're using polyatomic ions? To write our correct formula, we're going to write it just like we did with binary ionic compounds. We're going to make sure that the total charges add up to 0. So here with calcium nitrate, we have 1 calcium with a +2 charge. We have 2 nitrates with a -1 charge, so it adds up to 0. So we determined that we need 2 nitrates. So 1 calcium ion, 2 nitrate ions is going to give us calcium nitrate. Notice that that 2 as a subscript goes outside of parentheses. So the whole polyatomic ion is inside the parentheses. And then outside of that, we have a subscript showing how many of the polyatomic ion we have. So quick overview, we identify the cation and the polyatomic ion. We're going to make sure our charges sum to 0, and we're going to write the formula, cation first, and use subscripts to make sure our compound is neutral, just like we've been doing with our binary. The only difference is that now we have a polyatomic ion, so if there's a subscript on that, it goes inside parentheses. So let's just double check. So if we were asked to write the formula for aluminum hydrogen carbonate, first thing we're going to do is identify our cation and our polyatomic ion. So our cation is the aluminum ion, and our polyatomic ion is hydrogen carbonate. So we look at our table of polyatomic ions, and we would see that carbonate is CO3 -2. When we add the hydrogen, it becomes -1, and that's hydrogen carbonate. Now we need to make sure that our charges sum to 0. Aluminum is +3. Each hydrogen carbonate is only -1. So I need 3 of those. So that 3 is going to be a subscript in my formula. So we have the aluminum and 3 bicarbonate ions, and that gives us aluminum bicarbonate or aluminum hydrogen carbonate. Sorry, hydrogen carbonate and bicarbonate are the same thing. Okay, so now naming them. So if we can write the formula, now we have to be able to go from formula to name. So when we're naming them, we're going to name them just like we did the binary compounds. We're going to write the name of the positive ion first. We're going to write the name of the polyatomic ion last. If it is a type 2, we're going to put the charge of the metal in Roman numerals after the name of the metal. So as an example, we look at this one, we recognize that this is a polyatomic ion. We look it up on our chart and we see that its name is sulfate, and we have sodium sulfate. We recognize this group of nonmetals is a polyatomic ion. We look up its name, we see that it's phosphate. We're going to look up its charge so that we know what the charge of iron is. And we find that the charge of phosphate is -3. So the charge of iron has to be +3. So we're going to name this iron 3 phosphate. And one last time, we're looking at this polyatomic ion. We see that it's carbonate. We are going to then name the metal first, aluminum, and the polyatomic ion second, carbonate. So identify the cation and the polyatomic ion, name the cation, use a Roman numeral if you need to, name the polyatomic ion, and then write the name for the compound, cation, polyatomic ion. All right, quick check. So we're going to name these 2 compounds. So first we're going to look at our periodic table, and we're going to see that K is potassium. And we're going to look at our table of polyatomic ions, and we're going to see that ClO3 is chlorate. And we're going to name this potassium chlorate. For the second one, we're going to look at our periodic table, and we're going to see that Mn is a transition metal. So we know that we need to say its charge, and its name is manganese. So in order to figure out its charge, we're going to look at the charge of this polyatomic ion. We look it up on our table. We see that the polyatomic ion's name is hydroxide, and it has a charge of -1. Since there are 2 of them, we know the total charge here is -2, which means the total charge on my manganese must be +2. So this is manganese 2 hydroxide. So we're going from formula to name, same as binary, except that instead of ending in "ide," it's going to end in "ate" or "ite." Still have to name the charge if it is a type 2 metal. So quick overview, cation first, then anion. Our monatomic cation is going to be the name of the element plus a Roman numeral if it's a transition metal. And then our polyatomic anion, we're going to give it its own name. As an example, we have chlorate here. So we have calcium chlorate. I look forward to seeing you in class. As always, if you have any questions, let me know, and I'll see you soon.